The first step is to make an RC car, because you can't have a flying car without the car first. If only it were that easy. This project will require some new tools. Sure, I already have a soldering iron, but as a mechie, I really only use it to melt PLA back together, which makes it no good for actual soldering. So after a quick trip to Micro Center, Lowe's, and Amazon, I had the tools necessary to begin butchering some electronics. I started by putting connectors onto the ESCs and getting a power line connected to get an idea of whether or not I could even get just one of these to work, a little electrical tape for safety, and my first real soldering was done. Then I removed my LiPo battery from the daisy chain of connectors attached to the cheapest charger I could find online, and I was ready to go. Well, not so fast. My knockoff Nintendo Switch controller refuses to find my Bluetooth receiver, but both of them can connect to my phone, so if I could create a software bridge to relay commands from the controller to the receiver, then I could spend no extra money and have something that might work. And that's super easy. It just involves downloading Android Studio and teaching myself how to program my own custom app. Thanks for YouTube for some guidance there. Unfortunately, my Arduino Bluetooth receiver will only accept character values as inputs, which leaves me with just under 100 unique values I can work with. Assigning each of the 15 buttons of the controller a unique value leaves me with only 8 or 9 granular steps for the 4 directions of the 2 joysticks. That'll probably make tuning a flying object difficult, but what's life without a little bit of challenge? Some arts and crafts later then got me this graphical user interface that will definitely win some awards for its stunning graphics. After more coding, this time in Arduino, we finally should be able to move some stuff. Let's go! Let's go! With that brief, yet somehow too long, summary of about a month of my life out of the way, we can move on to the fun part, designing and manufacturing parts for the car. After many hours of CAD, I arrived at some test designs for getting started. With some creative utilization of floor space, and at the cost of my electric bill, I was able to bring these designs to life through 3D printing. Splitting the workload across printers helped decrease overall print time, and justify, to myself at least, why I own multiple 3D printers. Since motors and wheels spin, some bulk skateboard bearings, methodically hammered into place, should do the trick. Well, it's fun, which was apparently enough for me to justify designing the rest of the pieces and printing them all out. The prototype with the slipping belt was an oversight on my part, as I made the plate thinner to speed up print time without considering what that would do to the belt tension. Remedying that oversight, as well as programming, wiring, and testing servo for steering, I could now assemble the first iteration of the car. That, of course, meant disassembling the prototype first, which was loads of fun with some really short Allen keys and a cheap pair of needle nose pliers. In hindsight, not remembering that I owned a drill and hex bits makes this really, really sad. It's okay though, luckily assembly is quick. If only. Please enjoy this sped up time lapse of the assembly process. Hopefully you can derive some joy from my pain and suffering. Tethered drive test, take 1. Well, that sorta worked. Huh. Yoink. There we go. Untethered drive test, take 1. seems to be some slippage. Ah yes, clean linear motion, just like I wanted. Well, after a couple 3D printed TPU belt designs, it might just be that material designed to melt will melt under high friction. Who knew? A quick McMaster-Carr order later, and this should allow us to buy ourselves out of the problem. I'll need new pulleys to accommodate the size, and oh, would you look at that? Now the pulleys are melting themselves. Neat! What about gears? That ensures that we don't have slippage, which should help, right? Okay, well, they seem to have melted each other instead. Perhaps the teeth are too small. I learned something about involute curves in college and how they are important to get gears working. The 3D printer probably just couldn't print the detail I put into the design, and that's why they didn't work. Perhaps if I use fewer and larger teeth and actually do the curves properly, maybe it'll work. I'll also lower the kV of the motor I am using, which should increase the torque, or at least that's what a blog post on the internet said. Here we go. Well, while I think about that, let's solve a different problem. The ESCs I'm using are designed for drones and only go in one direction. That's not ideal for driving, as I will probably want to go backwards at some point. Of course, the reversible ones I purchased do not have the same sized bullet connectors as the ones that I used to have, so I have to try to fix that. Now, for anyone who solders at home, what you're about to see should not be replicated, and I apologize in advance. I am indeed crimping smaller wire to larger wire that all comes from a battery because I don't have the right connectors to make everything go together. Spoiler alert, I fixed this later and I realized it's a miracle that I didn't burn my apartment down. But the reason I'm doing this is so that the power and the ESCs are both on ring terminals, which will allow me to connect multiple ESCs in parallel to one power source. All my power transmission issues emanate from my desire to only use one motor to drive the car. Setting that stupid restriction aside and realizing that my ring terminal strategy will give me the ability to have two separate ESCs and two motors, I get this. Which works pretty well until I realize I somehow broke an axle. Luckily, I still have my trusty soldering iron. We might be really getting somewhere with this. It does seem, however, that quick soldering iron fixes won't solve the underlying axle problem. I was trying to think ahead and make parts lighter for when I try to make this thing fly. Axles, however, are definitely load bearing, and I guess I can justify 100% infill instead of this partial infill. There's also a bit of give in the wheelbase, which I can solve with a simple thrust bearing. Those changes really helped. If you ignore how poor of a driver I am and how poor of a cameraman, then you can really see the car doing all the movements it's supposed to. Since I have to use my phone to film as well as to act as a bridge for the signal from the controller to the car, and since I have to use two hands to drive the car, I'll probably have to develop a better way of recording so that this is easier to watch. Aside from the tires sliding off the wheel wells, this seems to be working. Let's add some fancy rims to hold the tires on, because that seems to be worth the added weight. Huh. It seems those rims added mass in such a way that the wheels violently shake the whole car and disconnect the electronics. I'll fix that later. Well, with a functional enough drive base, we can move on to flight. And
and since you clicked on this video probably expecting to see some of that, here's a tidbit of what's to come in the next video. Feel free to subscribe if you want to see what happens next. It's mostly filmed, I just need to get around to editing it all. See ya!